Hey everybody, it's IT1 Deal. I wanted to go ahead and post a video up of my EXXI, my CCIE lab, and I just wanted to talk a little bit about what I'm running over here, and hopefully I can show you um, my infrastructure, and maybe it can motivate you to build your own infrastructure. So what I'm running is I'm running a MacBook Pro. That's what I'm recording off right now. MacBook Pro, 16 gig solid state, but the machine that I'm actually running according to my diagram, which I'm going to pull up for you right here. So I'm over here on this machine, and basically what we have is a connection. I have AT&T here going through my modem. And then I have my two firewalls, my lab firewall that's specifically to block traffic sort of this way to kind of keep this network segregated so users can just come in here and practice on the training lab, and then also my home lab so I can have or not my home lab, but I should say my just actual home infrastructure. Regular iPads and Fire Sticks and all that good stuff. Just regular, just for the regular home use, not just for labbing, right? So the EXXI server in itself is the old Mac Pro, the old Mac Pro 1.1s, which are these models. If you're not familiar with Mac, is these guys. So what I did was I was looking around on Craigslist, and just back out of there because we'll need to look at that. I was looking around on Craigslist, and I found this Mac for about $300. Then I slapped 32 gigs of RAM in there, a solid state, and it was a dual core processor, and I upgraded to dual quad core, so I got 8 cores running in there, and it's awesome. I think I spent maybe about $250 for the upgrade, so all in total 550. But it gives me a great performance and power for running the virtual environment. And as you can see here on the diagram, I got quite a few machines in here. So I have a Windows 2010 virtual machine which I'm running Wireshark on. So I wanted to see um, what Win 10 was going to look like. So I used a virtual environment because I don't want to deploy it on a real environment because I don't even trust Windows. But you have to be diverse. So I just checked it out. Then I have all my different routers, and these routers, this infrastructure is based off the INE topology. So if you Google CCIE INE or INE topology, you'll come across what it has. Mine's is more in a logical sense. They just have the cloud, and then they'll have the four switches here. And this V switch right here is just a virtual switch. It's built inside of the actual EXXI server, and I will remote into the EXXI so you can see what it looks like. So I have that, and then I have this Windows Server 2008 machine that I wanted to practice authentication stuff with the Radius. Excuse me. I wanted to practice some of that in here, and so I have that. So between this virtual environment and this link right here that's going over to switch one, there is a switch in between, a breakout switch. So this is really what it is. So really my diagram should have this link going over here, more like, oh, I can't draw on it, but it should be going from here to here. But logically it's actually connected, directly connected to here. And then I also have one link that's going to the breakout switch. That's how I get internet, and then that's how you're also able to get in. So let's go and get in. So in the diagram, I forgot to draw probably one of the most important parts of this lab, which is the APC. This is the management console where you can get in and actually power on the equipment. So what I did was, let me start from the front. What I did was I logged into this APC power management, and all it is a network enabled power strip. So pretty much you can remote into it. then it's always has power, but the circuit is open. Uh, so then there's no power applied. And then when you go into the outlets, you can see each one of the devices listed there, and you can actually control each device by itself specifically. Like if you wanted to turn it on, delay it on, or you can just go to the master switch, and this is just like flipping. In your little surge protector, you flip that orange switch, and it'll turn everything on. So we're just gonna turn everything on. I'm gonna go ahead and apply that. So now that's on. It's gonna take a second to boot up all of the machines, but everything already is running as far as the hardware, the software, or excuse me, the EXXI, the routers inside of the virtual environment. This is already on because this portion is on a different power circuit, but mainly those pieces of gear you seen was the switches and the firewalls. So you won't be able to get in to the lab without the firewalls being on, and you won't be able to get into the switches without the firewalls being on. So what I'm going to do is I'm going to pull up Zoc 7, which is my terminal emulator, and you don't need any special terminal emulator or any specific platform. We're talking about getting on the command line. So if you got any kind of terminal emulator out there, I know they're super putty. If you have the money, it's great. It's secure CRT. It's like $100. They give you a 30-day free trial. But if you do have it and you want to manage multiple devices, that's probably the biggest benefit. You can manage multiple devices, i.e., send out commands all at once. This is great. But for the free stuff, man, for as far as doing your labs, there's any terminal emulator. You have your built-in. If you're on a Mac, you have your built-in terminal that you can, do your telnet and stuff from. But I like this because I have a directory in here. And as you can see, there's all my devices. So the APC, which we were on, which I enabled telnet for the console server. This is a 2511. Let me just show you what this looks like real quick. Okay, so this guy right here. So this, what you use this for basically is, this gives you 16 asynchronous links, and on the back of your switches you have your console ports. So what you do is you take your console cable, or rollover cable, excuse me, and you're gonna plug this into the different synchronous ports here. And what this does is like a management console for all your other devices. So if you wanted to hook, let's say, 16 switches up, and instead of remoting into each switch, you can remote into the console, and then from the console you can write a IP host, a little alias for each switch, and then you just press whatever switch you want, and then you're able to get in there. So this is really, really cool and really nifty if you have multiple devices. It works for routers too. It works for actually any device that has a console. You set the baud rate, 96, 8, 1, and none, or whichever rate that you want to set, and then you go ahead and hook that device into whichever port, and you tie the port to the device name, and then you're good to go. So that is the first one in that list right there. And then we have all of our routers. So all of our routers, this is the EXXI server's IP address, the .10. And then what I did was I just tied the port number to each individual device. So 1, 10 because it's 10, but 2, 3, 4, 5, 6, 7, 8, 9, all of them are tied in there. So what I can do is I'm just going to go ahead and open up all of them. And what I like about this Zoc 7 is if you want to open up everything, you can select it, select all, and it gets you all the devices opened, and you can do as much as you want, or you can just make it as very simple if you only want to open up one. But I'm just going to open up all 10 so you guys can see how it goes. So here I am on router 1, and let me just move this console back so you can see. So here we're on this router right here, and basically I'm able to run a full iOS 15.5, the new stuff. These are the CSR 1000V virtual routers. This is what Amazon is using for most of their network infrastructure. It's not an actual physical piece of gear. It's in the same kind of environment, maybe a little bit more beefed up than what I have here, but they probably have some kind of server with massive amounts of RAM, and they virtualize everything. It's kind of the way to go. If you're used to using like VirtualBox, just think of each router being like a very small OS. So this is just it's Linux based. So it's just like running a Linux OS in VirtualBox, but you're just deploying, a number of these devices into this EXXI server, which is the host for those devices, right? So we can do our standard commands, but I want to do a show CDP neighbors. So right now you can see this device is connected to that breakout switch, which is here, right? So there's a pass through in between, and since this EXXI is accepting all VLANs, it can show and see that this link is connected there. Just like if we go on router 2, now on this one probably got the CDP information while we're waiting on it, but you can see this device can see all the different routers. So it can see 3, 4, 5, 5, 6. It can't see one. So maybe I have this one in a different net. Let's see. Yeah, I think I have this one in a different network, but from the old config. But you can see all the different devices there, and of course you can see the switch, the 3560, which is on Fast Ethernet 01. This is the breakout switch, which is this guy right here. So we should be able to do that. Yeah, they're all coming up. So they're just all coming out. Oops, excuse me. Okay, yeah, so they're all coming up. So you can see all of those. So I'm going to go ahead and open up the switches as well. So with the switches, I always leave them blank, so they're going to come up with no configuration. But I always do this because let's say you want to work on a different lab, a different technology, instead of always leaving the configurations in there and then doing a erase start and then reloading your router. This new option, which I really like, allows you to actually do it's called configure replace, and this slides a new configuration right. It's like doing a swap of configurations. So it's like taking off your shoe and swapping it with a different shoe. So it doesn't really change or get rid of any other different configurations you had before where you have to reload it. You can just slide the new configuration in there. So what I'm going to do real quick is show you guys how it works and load up the trunk links. So I want all trunk links between all of these different devices right here. And these are 2 cables. I'm sorry you can't really see it, but there's 2 on 19 and 20, 21, 22, 23, 24 on all ports, going all 2 links going each way for dual trunkings. Okay, so I'm going to do enable, and I'm just going to do configure replace flash, and I have a file name all trunks config. And what this does is you'll see that right now it just has it as switch, and what it's going to ask me to do, I want to replace. It's going to say these will all apply to necessary, and delete the replace and run in the current running configuration. So I want to say yes to that, and then it should give me there we go. It should give me a new interface. It should come up as switch 4 once it's done. Yeah, there we go. So do the same thing for switch 2. No. And you see how faster this is if you were trying to load up a whole bunch of configurations and you're like, man, I gotta go and do a copy run start to each one, and excuse me, and have to go over and over doing them instead of just dropping it in like how I did there. So now the switch will come up and you just have your configuration. And what you can do is you can build specific configurations based on what you want to practice. Let's say you want to, we're on the switches. Let's say you want to practice VTP, or maybe you want to practice Ether channel or whatever. You can set your configuration, build it up, then save that configuration to Flash. And then when you want to practice that technology, you just use that configure replace command and it'll drop right in there. So I think did we get 4? Okay, we got 4, so we just need to do 3. So on router 3, this is also on newer equipment. So if you don't have newer equipment, this is a 3550, I want to say. 3550. And let's say you don't have new equipment, you can still do the same thing. It's not the exact same thing, but you can do the same content. So you're just going to do config T, and then you're going to do you can do copy. Oops, we don't even need to be over there. We need to do copy Flash to running config, and then I have that same source file name, all trunks config, or whatever you want to name it, right? And then boom, switch 3, we're up there. So it copied that and threw it in there in running configuration. So for the older devices, if you just had one older device, like I have this older 3550, I'm waiting on a new 3750s to come in to replace this one. But if you have an older one, you can still do that. And it's you think that, hey, this is also virtualized, is on a solid state. If I do a erase, start, and reload just on one device, it won't be that bad, because look at, I was dropping the commands in between. I probably should have started with that one first, and by the time it boots back up, you'll be good to go. So I just want to make sure we got everything synced up. Show CDP neighbors. Okay, so now you can see that I have these links between the devices. So you can see I have switch 3, I have 2 links at 19 and 20, and switch 2, I have links at 23 and 24. Switch 3, switch 2, and then this should be, I don't know what this one is, 19 and 20. I don't know, I got a dupe in there. Let me see, what is that? To show CDP neighbor. Let me go on another switch and see what that is. Show CDP neighbor. Switch 1, switch 3, switch 4, switch 2. It's really weird. I don't know what that is, but I have to go check that out and go check on my wiring and see. I think what it is, it's replicating the same. This is 21 and 22. 3550. I think the 3550 is sending the same information out again, but we can clear that. So now I have my whole infrastructure up and ready, and now let's say I want to practice a specific technology. I can do that same thing on my routers, on my virtual routers. So I can do configure replace Flash, and actually let me show you. I'm gonna do the basic RIP routing, right? So I'm gonna do configure replace Flash, basic RIP routing. I'm just gonna take this command and copy it everywhere. So it's going to get all my configurations ready. Oops. Type in yes before I even type the command. And you can see how this, I know this is tedious right here, but this is a lot faster when you're labbing, because you don't want to be wasting time trying to configure your routers just to get into the configuration for what you're trying to practice, right? So let's say, you want to do some basic basic RIP routing. So instead of setting up what I'm going to show you right here, which is show run, instead of setting up this configuration with all this information, you already have it preloaded. You know, you do the grunt work before. And what's nice is I actually pull these configs. This is part of the training from INE. So they were nice enough to just go ahead and build it. But when you're talking about your CCNA level and even CCNP level configurations, you don't want to, the test is not to test you on really like how well you can do the configurations per se. You want to actually focus on executing the technology or understanding the technology. So if they ask you a question about, let's say for example, right, they want to know what this information is right here. What does it mean that this 155.1.0.0/16? They're going to ask you, hey, what subnet mask is that? You know, they're going to try to decipher if you can understand this information that's in a show command. When I was going through my CCNP, there's a lot of sections in there where they want to see what can you pull information out of a show version, or can you pull information out of show controllers, for example, or can you decipher these commands up here? Do you know that C means connected, that it's locally there? Do you know that RIP is that when you see a R over here in the routing on the protocols for the devices, that you can associate RIP with that and understand what it means? That's what they're going to be asking you for. So instead of you just doing banging away configurations all day, which is good practice, but you want to understand what's going on with the technology. Why do you use EIGRP over RIP or OSPF, or even when you start getting into your higher level certification, BGP, ISIS? Why are you using that technology? Can you shape the shape the traffic or shape the packet to go a different way based on how the network design is? And the same thing applies on the switch level, right? They want to know if you can understand when you look at this. So when you're looking at a show spanning tree, right? Can you tell me which bridge is the root bridge? Can you tell me what is the priority for this switch? Does this mean anything to you, right? Does these devices all in blocking mean anything to you? If I do VLAN 1 priority 0. So do you understand what this is, right? It's in a listening stage, and these ports are in forwarding, right? And as we do, if we keep doing that, you should see that it's going through the different stages of listening, learning, and then it's gonna still learning, but it's gonna go through its cycles of finding out what's going on with the topology. And you can see that this bridge is the root. Now, I just manually made this bridge the root because if you were, I don't know, I didn't really point to it. But before, when you seen it, this bridge was not the root because the cost was 19 here, right? So this was locally connected. It's connected to the bridge. That was the root bridge. But now if you look, because I made it, the priority was 1. So lowest priority, right, makes a bridge the root bridge. So now all these are in a blocking state because this is the root bridge. Now I don't know what's going on with 24. Maybe it's not updating. Let me see what's going on with that bad boy. Okay, there we go. So see now how all links are now in a forwarding state. That's exactly what you want to see from the root bridge because they're going to be passing out the information. So same thing if you were doing so we're in VTP server mode, right? And we're going to make our VTP name IT. Let's make it rocks. I don't know if we can throw that colon in there. I don't think we can do that. Okay, it did work. Right on. So now if we do show VTP status, right now the VTP name, domain name is CCIE. So now see, it said that we can't perform trunk negotiation because of a VTP domain mismatch. And pretty much what that's saying is because these names are different, CCIE over here, and we named it to IT Rocks, we're going to get that error because it doesn't know how to exchange information. Now, if I go and I change that, that's how to put it, right? IT's Rocks. And I add a VLAN over here, so let's do VLAN 1, 3, and 1 through 3. Okay. So now, in a few seconds, I should be able to, what I should have did was show VLAN. Maybe I'll get it before it shows up. But you see we had VLANs 1, 5, 6, 7, and 8. So now we should get VLANs 1, 2, and 3 when we get the update. Might take a second. Okay, so we'll wait till it updates. It might take a little second, but basically keep hitting that. Let me just double check something because that shouldn't take that long. Okay. I just wanted to see if it took the domain name and if it was taking the updates. Show VTP status. Okay, revision 1, 1005. Okay. I don't know why it's not doing it. I need to check it in there. It's still a lab building, but basically now I'm ready to go. Now that I have all of my configurations loaded here on all the different routers. Show run. So I have all my devices here connected up, and now I can pretty much start labbing. So, and getting to figure out what's going on over here on switch 2 and why that VLAN's not spanning across. But let's say you're like, whoa, man, you got all this servers and all this, crazy diagram and switches and all of this stuff. What if I don't have the dough for that? What if you don't have money to invest into that? Okay, well, I got a solution for you still. That still doesn't stop your training. So I have a program called GNS3, and this is a very useful tool if you don't want to get into the full lab. And now I know the first question is going to be like, well, why aren't you using GNS3? GNS3 has its limitations, and it doesn't give me the full scope that I need for CCIE. But as far as for CCNA and CCNP, as far as the routing portion, this should get you to where you need to get to, because CCNA, you need to just get on a command line and kind of get familiar with some show commands and understand what's going on and see it. And if you don't want to buy gear and you kind of want something portable, like I said, this is on my laptop right here. This is something else. Oh, there's a new update. This is something else that you can use. So what I did was, let me start first. So this is just a blank template. I just started a blank template. And here in the buttons, you have all your different routing devices. Then you have all your switching devices. So we know this is the icon for routers. This is the icon for switches. and then you got end devices. You can put host in here. Now, GNS3 is a very powerful tool. Don't underplay it or don't downplay it, because you can actually do a lot with GNS3. People actually run infrastructure, like live infrastructure, off of GNS3. They use it in the same way the EXXI is being used. They have a computer, they run GNS3, it has multiple NICs on it, and they route traffic through their network, and they're able to do it all through this model. So, excuse me, through here, we can load up a couple of devices. So I'm gonna pick a 7200 series router because this is at the level of CCIE, but it doesn't really matter. What you really need is command line time, in my opinion. It's just time to get on there. For me, I know a lot of people, when I talk to them and they're talking about Cisco certification, it's about getting familiar with the command line interfaces and applying what they're reading in the book and applying it to the routers, right? So I just got 3 routers here, and let's connect these bad boys up. So what I did was, over here you have your connections, and you just go ahead and link these up, right? So we're gonna link up fast Ethernet 0 to 0 and fast Ethernet 2 and 2. So one cool feature about these routers is that you can come in here, and if you right click on it, or if you're on a Mac, control click and get configure, you can come in here and actually change what's in here. So if you want different slots, if you want to add OC3 connectors, if you even know what that is, it's just a different type of interface. If you want to add serial interfaces, some devices will let you add serials, some won't. But if you want to add devices based on the technology you're trying to execute, you can add them in here and customize your router. So what I'm going to do is I'm just going to name these real quick so we know with the IP address range. So we're going to do, this is going to be, do I have enough routers? I do. So it's going to be the 10 network. Okay, it won't let me do it. How about I just write it? 10.0.0.0.24. So what I'm going to do is, am I missing a router? I'm not. I'm going to just show you guys exactly what it can do. It's the same powerful tool, just like if you had real equipment. And I don't know if anybody's been over to ANA, but this is what we used to do back in the day. We used to do these 10, 20, 30 networks just to explain how routing protocol works. And this is how I first learned how RIP works, right? So what I'm going to do is I'm going to go ahead and power these devices on right here. Now you can power them all on individually by going to the device, and it'll light up there, or you can just hit the play. Now, based on what kind of system you're running, you might want to power them on one at a time, because they do use the system's RAM. So if you're running 20 routers, you don't want to just power them all on at once. You want to cycle them or cascade them when they power on. And so they're powering up, they're booting up, and the same thing, you click on it, and you're going to get that same, sorry about the matrix green, but you're going to get the same thing like how if we were booted up and one of these routers over here on the ZOC. It's going to be the same. Let me go on router. It's going to look exactly the same. Let me actually move this window over here so we can all see, so I can swap between each one. So I'm on router 1, right? And what I'm going to do is I'm just going to do a basic RIP network just so you can see the routing protocol. So what I'm going to do is I'm going to give this interface right here a .1, and I'm going to give this interface .2. Actually, no, I'm not going to do that, because I need to add another router. What I'm going to do is I'm just going to make the 20 network a loopback interface. So I'm going to do the same thing on this side though. I'm going to do dot 2 and dot 1. So I'll explain when I get in there. Okay, so on router 1, we're going to go configure terminal, and we're going to go interface fast Ethernet 0/0, which is this guy right here. And we're going to do IP address 10.0.0.1, 255.255.255.0 for the CIDR of 24. We're going to do a no shutdown to bring that interface up. Okay, so line protocol 5 change state to up. Perfect. And I'm going to go over to router 2 now. And what I'll do is, to make it look easier, I'm going to merge all windows. Sorry, I was looking for that. Okay, so now we're on router 2, and what I'm going to do is I'm going to go ahead and configure this interface, which is the fast Ethernet 0/0. Interface fast Ethernet 0/0, and we're going to give it that dot 2. So I'm going to do IP address 10.0.0.2, 255.255.255.0. We're going to do a no shut, and that interface should come up. So let's just do a ping test real quick and ping over to 10.0.0.1. Alright, boom. So it learned the ARP at first, trying to figure out where it's at, and it's up. So now for the middle interface, we're going to just make a loopback interface. So we're going to go interface, configure terminal, and then we're going to do interface loopback 0. And we're going to give it an IP address of 20.0.0.1, and we'll give it a subnet mask of 255.255.255.0. Usually loopback interfaces come up by themselves, but it's just such a I don't call it a bad habit. It's just a habit of me bringing an interface back up, doing a no shut. So I brought that interface back up, and now we should be good. So we should be able to ping that device, of course, because it's here locally. Boom, okay. So on the other side of the device, we got that fast Ethernet 2/0, so we're going to go ahead and configure that as well. So we're going to go configure terminal. We're going to go interface fast Ethernet 2/0. We're going to go IP address 30 0.0.2 255.255.255.0 and do a no shut. So that interface came back up, and now we'll go over to router 3. Just merge them all in there so we can have it. Bring that out there so we can move this so we can see what we're doing. I hope you can see that. Okay, so on router 3, we're going to go ahead and do configure terminal. We're going to do interface fast Ethernet 2/0. We're going to do IP address 30.0.0.1 with a subnet mask of WAC24 255.255.255.0. I'm going to do a no shut on that interface as well. So now we have everything configured. So now if I do a show IP route, it's going to tell us about the devices that we know that are locally connected, right? So this network, or this device, only knows about the 30 network. That is what we configured on our interface, right? So show IP interface brief. And that's the only one that we connected, the 30.1. So you can't, so my question is, can you ping that 10 network over there? Well, it's connected, right? We should be able to just go across, right? No, we won't be able to ping it because we only know about directly connected networks. So if it's not in this routing table, we don't know about it, right? So ping. So you're like, we know about the 30 across this link, right? But we don't know about the 20 network, right? Ping 20.0.0.1. We don't know about the 20 network, and we don't know about the 20 networks from router 1's perspective as well. We know about our networks, right? The 10s, so we should be able to ping 10.0.0.1 and .2, but we can't ping 20.0.0.1. So this is where the routing protocol comes into play as far as passing the information over from the routers to tell the packet how to get from point A to point B. So what we're going to do is I'm going to start on router 1, and we're going to use a routing protocol. So let me just show you proute. So all these are the different routing protocols that we can use, but in particular, you're probably going to want to use static, which I can talk about later, but this is like a directed route. You tell it exactly how to get there. RIP. Oh, and let me get back on static real quick. Static is kind of one-dimensional, as in if you tell it how to get there, we're going to tell this router, if you want to get to the 30 network, it's via the 20 network, and that route goes down. It will not it will not know how to get back over to the 30 network because it's static. It's not like a routing protocol where it's more kind of dynamic, and it can learn. It can learn about new ways to get over to that 30 network. Let's say we added a direct link here to get there, and we had a routing protocol running, but because of the static cost is the best cost. It would always choose the static route. So static is if you want traffic to do a very specific, travel a very specific way. So you have RIP, BGP, that's more for the service provider, but for IGPs internal, you're going to use RIP, EIGRP, and OSPF. So we're going to do EIGRP. So to implement that, all you're going to do is you're going to come here, go to configure terminal, and you're going to type in router, and then here are the different routing protocols. So we're going to do EIGRP, and then it's going to ask for a word, which is this is like the new type of EIGRP, but the old way of doing it is with just an autonomous system number, which is a number. So you can just give it a number, and that's going to be for that specific instance. So we're just going to say 10, right? And then we're going to tell it the networks that we want to advertise. So we want to advertise network 10.0.0.0. Now, if we wanted to advertise something very specific, we can also add the wildcard bits, which is the inverse subnet mask. So if we have a subnet mask of 255.255.255.255.0. So the inverse of that is wherever there's a 255, there's going to be a 0. So it will actually be 0.0.0.255. And you can look it up on online, and you can see the CIDR chart, and you'll see the inverse wildcard. But all you're going to do is count where there's a 1, there's a 0. So enough about that. So we just put this network in here, 10, and then we're done. So now we need to just go over to the next router, which is router 2. And now I'm just going to take this one out because I want to show you what happens when the routing protocol starts passing the information. So let me get router 1. I'm just going to debug neighbors. So what I did was I just turned on the debugging of showing when the neighbor adjacencies are started, so you can see how fast the convergence is once we advertise that network. So I'm going to go in here to configure terminal, and then I'm going to do router again, EIGRP, and I have to make sure I have the same autonomous system number as 10. And I'm going to do network. We want to advertise that 20 network, and we also want to advertise the 10 network. So after I hit this, what should happen is we should see the neighbor adjacency established between router 1 and router 2. So we got this right here. We got the dual neighbor adjacency, neighbor 10.0.0.2. This is who sent it. There's a new link up. So basically what the router says, hey, we got some new information from this dude over here from the source 10.0.0.2. So let's check it out and see what we got. So to see, you're going to do a show IP route. And now we have this new route in here, this D, which is EIGRP. And we now know about the 20 network. And this is the route. So the 20 network is via 10.0.0.2. So what they're saying is, if you want to get to the 20 network, send your traffic out of this one with the destination of 10.0.0.2, and you will be able to reach that 20 network. So now let's just test and see. Pinged 20.0.0.1. Boom, we can hit it. So we're going to do the same thing for router 3. I'm going to go configure terminal. We're going to do router EIGRP 10 for the autonomous system number. And we're going to do network. And we're going to do 30 network. And now let me pull these all out so you can see. And we'll get back to the screen right there. But I just want to show you when the convergence happens. Let me move that one back up there so you can see. And I'm sorry, I forgot to do the 30 network over here as well. Interface, oops, excuse me, router, EIGRP 10, network, 30.0.0.0, end. So now you got adjacency here. It says I got a new adjacency from this neighbor on 30.0.0.2. And what's going to happen is, if I go over here, we just looked at our routing table, right? We only had the 20 network in there. Now when I do a show IP route, we should have the 30 network in there. So now we know about the 20 network and the 30 network, and vice versa. On here, we didn't do a show IP route, but I should be able to see the 10 network now too. So now I can see the 10 network. So, and same thing over here on router 3. So now let's merge them all back. So now from router 3, when we weren't able to get all the way over here, we can only get to this outside interface. Now I can go all the way across, right? So I can go ping 10.0.0.1. Boom. Right? And we can do a trace route as well. And it should tell us that we're going to go through the 20. Oops, excuse me. We're going to go through the 20 or the 30 network and then over to the 10 network. So this tool, which you can download if you just Google GNS3, you can download this, and this is extremely powerful if you want to start practicing. If you want to start practicing some basic routing. I don't want to say it's just basic. I don't want to just downplay it like it's basic. You can actually do, like I said, you can do some pretty powerful stuff in here. But your iOSs, you can grab your iOSs from this link right here. And here's all your iOSs. So some of these links, some of them do work. Some of them are kind of, bleh. But the 2600 series routers are there. They're pretty good. You can do that. And all you do is when you get an iOS and you want to add one, you just come up here to preferences. You're going to come over to iOS router. You're going to hit new and then browse. And what you'll do is you'll browse for that image or that bin file. And once you browse and hit that file, wherever you have it at, wherever you have it stored, you're just going to select it. It might just tell me that I already have this one. And once you select it, it should say next. It might give you a prompt to say, do you want to decompress this image? I would say yes. Then on this one, you can change your platform, but this is a 7200 series router, so it's already in use. So, but after that, you will hit next and finish, and then your router will show up here in the device list, and then you'll have your routes. So you can leave this running. I do want to just show you this real quick before I get out of here. If you really want to get kind of savvy with it, talk to your ISP. I bought 5 static IPs from AT&T for like $5 additional a month, and now I have my own dedicated IPs. So you can actually take this and hook your GNS3 lab to the actual internet. There are some safety stuff you want to take in to consideration, but you can use this cloud interface. And what it does is, if you go ahead and attach this to whatever your Ethernet interface, on my Mac, this is Ethernet 0. I add that, and then I take a link, and I link it to the cloud. Technically, on my Ethernet interface on my Mac, I plug that into my modem with a static IP. I can assign a static IP on this interface, and I will be able to come through my modem, pinning your firewall, however your modem set up. But I would be able to remote straight in, just like how we did the remote into here. Like if I wanted to remote, let me just show you real quick. So I'm just going to make a new connection. And I'm going to do SSH. This is how I have it set up. I highly suggest that you set it up SSH when you're going to set up something. So I'm going to terminal into my firewall, or excuse me, SSH into my firewall. Okay. Sorry, but I got to put the username real quick. Okay. So then it's going to prompt me for a password, right? Oops. And now I'm on my firewall. So that picture that I showed you right here, this is our edge. So this is the firewall right here. So you can remote in, and like I said, I signed that IP, the static IP. You can get a DNS, or excuse me, you can get a FQDN. Like I didn't actually type the IP address. I got it registered through my website, but I actually linked that so that way you can just type that in instead of trying to remember IP address. But now I'm on my actual firewall, and you can come in there. And you can get in there and you can do whatever you want to do. You do show run, and you can see everything that's going on in there. But yeah, you can pretty much link that to your actual internet and practice. Let's say if you got time at work, I don't know if you're at home or excuse me, on a ship or overseas, but if you have the time and you're really serious about training, this is the kind of stuff that you're going to need. These kind of resources you're going to need, and I'm here for anybody who needs the assistance. I can try my hardest to help you. It's truly a passion for me, and it's a passion when I see the light, the face. When you figure it out, when you see, when you see this and what this actually means, and you start to get it, it starts to click for you. That's what I'm here for. That's what I do it for, solely for that. But if you need anything, just go ahead and hit me up on the Facebook page, or I drop my email in there. I'm going to drop my email at the end of the video, but feel free. And if we have these meetups again, we're going to try to do another meetup in next month. If you're free, just come out there. Bring your laptop. I'll bring my Switch this time because we're going to try to hook up GNS3. I'm trying to get a massive hookup to see if we can all hook our GNS3 infrastructure up to one switch, and we can start doing labs with each other. We can start basically building out infrastructure. And this is going to get you the most realistic feel of what it is to actually manage the network. So I know I kind of ran long, but I hope that this was informative. And like I said, if you have any questions about anything that's covered on here, just shoot me an email, and I look forward to your response. Thanks.